What is that? Hearse? Pretty funky hearse. I might be dead, but at least being transported in style. Okay. Solo, longer ride today. Cutting through the city. Is always a chore. This is the part of the city with lots of offices. So it does get busy. And it is a little bit of lunchtime now. So huh. Okay. Okay. That wasn't too bad. New route for me today. So I'm excited to see new part of the city. Should be able to avoid the rain according to the forecast, but nothing is for sure in Seattle. I don't think I've ever been here. Looks like a nice touristy area. Whenever I'm on the bike and just getting distracted by what's around me, keep hitting potholes and whatnot, keep getting reminded of how my dad used to drive, me growing up, we'd also always get distracted, not look where he's going. Where's this detour going? Okay. Yeah. So you end up becoming your parents, is what I'm saying. Look at that. So I guess, I don't know which part of the city this part is. Over there. This lake here is beautiful. Looks like we have tailwinds coming from the south. Or, I mean, wind coming from the south. It's a headwind right now. I'm moving south. What is this? I have no idea what this green thing is. Oh boy, it's steep. I used to live in Los Alamos before I moved to Seattle. It's in New Mexico, northern New Mexico, which is mountainous. So I find that here there are those short, very steep hills, whereas Los Alamos has more long, sustained climb. That's the slope here. Oh yeah, double digits already. 12%, it says 14%, 15%. It's pretty steep. So I think this would be over in like 3-4 minutes, maybe. I don't know what the average would be. Guess somewhere double digits as well. Still at 10%. And I can see it getting steeper out there. Whereas in Los Alamos, you get more of these 20-minute climbs with average like 7-8%. Okay, I think we're at the top now. This part looks like a European city, maybe somewhere on the coast of Italy or something. Something I would see in Milan San Remo or something like that, I don't know. My way back home now, heading north. Have a tailwind. It's pretty nice, always going home with a tailwind. This here is a nice trail. I was listening to a podcast by Trevor Noah. He was saying one of the reasons he does not want to get his US citizenship is because you want to know that if he committed a crime here in the US, thank you, that he will not be persecuted here in the US, but he'll be sent back to South Africa for that to happen, or I guess, like, yeah, get deported and go through the justice system in South Africa rather than here. And the reason he does not want to go through the justice system here is because of the jury system, which is indeed a weird system, I have to agree, where 12 regular people get to decide whether you're guilty or not. And the idea is like members of your community get to decide whether you're a threat to the community. Sound nice in practice, sorry, in theory. But yeah, when you think about it, I really don't want 12, well, I don't know what regular means, but I really don't want 12 regular people deciding anything about my future, really, let alone I'm guilty of a crime or not. And I was thinking about this, and this is actually one of my unreasonable fears, I guess, of being charged of a crime that I did not commit. I actually do get nightmares about this. And if that were to happen, I would want the people assessing the evidence. That's a nice church. Yeah, I would want the people assessing the evidence to have some understanding of statistics and Bayesian theorems and things like that. So there's always this example of like how hard it is really to explain Bayesian statistics, for example. To a regular person. And again, I use the term regular person in a, I don't know, I guess somebody who hasn't studied these things in detail. But there's this popular example that, I don't know, I got probably introduced to in sophomore year in college. It was one of these things that really blew my mind at the time. So, suppose you have a drug that tests for a disease, and this, a test for a disease that is 99.99% accurate. That is, if you have the disease and you got that test, the test is 99.99% accurate in that it will tell you you have the disease. Sound pretty good, right? But now I ask you, suppose you take the test and you test positive, what's the probability that you have the disease? Well, your first instinct is to say, well, clearly 99.99%, right? I definitely have this disease, I'm very confident in that. Whereas that, of course, if you know Bayesian statistics, would be the completely wrong conclusion. And the reason being, you gotta know something about the priors. So, really the 99.99% accuracy answers the question, given that you have the disease, what's the probability that you test positive? Whereas, that's not the question you're interested in, is it? You want to answer the question, given that you tested positive, what's the probability that you have the disease? Two very different questions. And the missing information here, well, is how rare is that disease? Right? And like intuitively, you should expect that the more rare the disease is, the less likely you'll have the disease, even if you tested positive. So for example, suppose I then tell you, oh, this disease is actually pretty rare. Like, let's say it only affects 1 in a million. 1 in a million. person in the population. With this piece of information and with some basic knowledge about Bayesian statistics, now we try to answer the question, what is the probability that you have the disease, given that you tested positive? Let you think about it for a while as you enjoy this view before I say what the answer should be. Well, I guess this here is one of the less nicer views. I also want to see where I'm going now. I'm off the trail. Oh, back on the trail. Yeah, so basically using Bayesian statistics and with the numbers that I just made up, and I made them up to make the math easy somewhat. Probability that you have the disease should be less than like 1 in a million over how accurate the test is. So about 0.01 probability, I think slightly less, which is less than 1%. It's less than 1% chance that you actually have the disease. And that's pretty striking. And I feel like even for reasonably, I'm wrong. Get lost a lot. Am I now in the right place? I think so. Okay. I don't like that. Yeah, and even for reasonably knowledgeable people, I feel like that's somewhat hard to explain really. And this has a lot of one could come up with a lot of examples in assessing evidence in court where misunderstandings like this or misinterpretation of the data like this can give false impression that the data is incriminating, whereas maybe it does not really mean what you think it means if you work out the probabilities. And I guess all of the examples would fall under the category of maybe you would be presented with data of probability of evidence given that you're innocent, and having that number be very, very small, and then it'd be like, okay, these evidence are very improbable if you are innocent. Whereas really the question you want to answer is not what is the probability of evidence given innocence, but what's the probability of innocence given the evidence. And without proper knowledge about priors, about the evidence, well, getting the right answer can be took the wrong turn. Can be very hard, and I don't know how you would explain that in court, that you're not using Bayesian statistics correctly. Sounds like a hard thing to, yeah, so that's kind of like the source of some of my nightmares, of me trying to explain why the data or the evidence do not mean what you think they mean. Anyway, I just thought Trevor Noah had a good point there. "14 kilometers to get back home. Starting to rain very lightly. I hope I make it back before it gets worse." This here is Lake Washington though. It's pretty nice. Also, I still have a tailwind, so we're cruising. Last little hill before I make it home. Think I'll beat the rain. Not a totally legal move, but I think it's justified. Oh. Okay. I think I have like 2 minutes. I think I made it. See you next time.